Yes, Vinay. Can you please label over here that what type of bonding would be present in each one of them? Obviously, fill it. Here is your bone. Fill it. Yes, please. I added one more compound.
What, sorry?
I added one more.
Okay.
Okay, it's okay, never mind. Listen, this is correct. Listen, stop. Stop, Umar, please. Okay, look. You identified that this is a metal, and you identified this is a non-metal. So you said it's ionic, isn't it?
Yeah.
Then you said that this is metal and this is non-metal, so this is ionic. These are both non-metals. So this is covalent. In covalent, what kind of covalent is this?
Which one? CH4?
But yeah, there are two types of covalent compounds, right?
Yeah,
What are they?
this one.
Beta, what is the name?
Covalent, single and covalent compound.
Simple covalent compound. And the other one is
Uh, co okay.
giant covalent compound. Right. Okay. And then this one over here is metallic. Okay. Because over here we have metal only. You got it?
Yeah.
Anyways, the lesson was more focused towards the dot and cross model. So let's do the dot and cross model. Okay. So we have
Okay.
magnesium chloride right now. And we know already that this is a metal and this is a non-metal. So that means it is ionic. When we have an ionic compound, we first of all break it up into ions. Okay. So this is the rough work we are doing. Okay. In order to be sure that our working would be correct. Are you getting that? Okay.
Yes.
So for example, we will have one, look over here. Nothing is written over here. That means one is written over here, right? So we will write over here one magnesium and then we will write two chlorines. Are you getting it? Then
Yes.
from the periodic table, we'll try to deduce that what is the charge on each one of them. Okay. So we basically have 1, 2, 3, 4, 5, 6, 7. Okay. And then 8. 8 groups, right? Okay. Let's talk about valency of each one of them, please. What is valency of group 1?
Uh, 1.
Positive 1.
Yeah.
Okay. What is valency for group 2?
Positive 2.
For group 3?
Positive 3.
4?
Positive 4.
5?
Minus 4.
Minus 3.
Minus 3.
For group 6?
-4.
Minus what?
-2.
Hmm. For group 7,
-1.
for group 8,
Uh, 0.
0. Right. Okay. Now what are we going to do is, for magnesium, magnesium is in which group? Magnesium is in group 2, right? So we will write 2 positive over here. Are you getting it? Hmm?
Yes.
Chlorine is in group 7, so we will write -1 over here. You got it?
Yes.
Okay. Then the other part of the rough work, which I believe should be integral in order to get an accurate diagram, is that we write cations electronic configuration, and then we write the neutral atoms electronic configuration and the anions electronic configuration. Are you getting that?
Yeah.
Can you please write over here the electronic configuration for each one of them?
Okay.
Listen, magnesium is 24 and 12, right? In order to write electronic configuration, we'll pick up the smaller number. So the neutral atom would be 282. But we will find out for magnesium ion, so over here we are doing +2, 2 positive, right? That means here we will do -2. Are you getting it? So it will become 28. Okay, fine. Before we even jump onto this one, I want to do a little activity with you. Okay, let's say we have over here 24 and 12. Okay. Electron, proton, and neutron. Hello.
Yes.
Beta, look over here. This is neutral atom, right? How come it's neutral? Because we have no charge over here, right? Okay. Now we see a number 12 written over here. So 12 is what? 12 is a proton number. So we write 12 over here. Are you getting it? Okay.
Yeah.
And in the in neutral atom, okay, in neutral atom, number of protons is equals to number of electrons. Are you getting it? Okay. So if protons are 12, so 12 would be electrons. You got it? Okay. In order to find neutrons, what do is we subtract these two numbers. Okay. So 24 minus 12 would be how much? It would be 12, isn't it?
Yes.
Okay. Then you see over here, we have 12 over here. So we write 12 again. Okay. So proton number is like identity of an element. Okay. It's like your roll number. Tell me, if I change your roll number, would you be the same person?
Yeah.
No, right? You come on. If let's say I'm entering the marks, okay, and let's say your roll number was 100, okay, and I enter your marks in 101 roll number. So would it be your marks then anymore?
No.
Of course not, right? It would be changed. Are you getting it? Okay. So the thing is that This 12, the proton number is identity of an element. Okay, if you change the proton number, you actually change the element. Are you getting it?
Yeah.
Okay. Okay. Then you see what happens is that we have over here 12 proton. Okay. So here what we'll do is we'll write 12 and over here we have 2 positive. So we'll do opposite of that. We'll do -2 over here. Are you getting it? Hmm?
Yeah.
Okay. So -2 would be what? It would be 10. Okay. And how many neutrons are there? For neutrons, we subtract these two values. So it would be 24 minus 12 and it would be 12. You got it?
Yeah.
Can you please do these two?
Okay. Where is this? Which slide? Oh,
3.
here.
Okay, that's great. Why did you write 16 over here directly? Bete, what are you doing? What are you doing? In proton, I told you to pick up the smaller number and I don't know, what are you doing with it? Huh?
So 8?
Sorry?
No, 16? What should I write in proton?
Proton number is the smaller number, no?
Okay.
change the electron number as well. Okay. All right, that's great. Are you getting it how to do it? Huh? Can you please
Yes.
now fix this? Huh?
No.
You don't want to change anything because this is chlorine -1.
Oh, it's -1. Okay.
Yes, please. Are you changing anything?
Yes.
Yeah, very good. Okay. So since now we have done our rough work, and now we know how many electrons do we have in the valence shell, right? So what do we do now is that we draw one circle to represent magnesium ion and the other circle for to represent the chloride ion. Okay. So first of all, we label over here Mg2 positive, then we label over here Cl negative, okay, and then we make up these square brackets over here. Are you getting that? Hmm? Okay. Then we write charges on top. With magnesium, we write 2 positive on top, and with chlorine, we write -1 over here. Okay. Then over here, we write the key. Okay. So for the key for magnesium is, let's say, it is a dot. Okay. And with chlorine, let's say it's a cross. Okay. So now we see how many electrons do we have in the magnesium outermost shell? Yes, please.
8.
8. Oh, sorry. We have selected a dot for it. So I will make 8 electrons over here. Are you getting it?
Okay.
And then over here, first of all, I'll make for neutral chlorine. Okay, so neutral chlorine has 7 electrons. So I will make 7 electrons over here. Are you getting it?
Yes.
And then in order to make it go 8, we are adding up 1 electron. So we'll add 1 more electron over here. Are you catching up?
Yes.
Over here, we write 1. We usually don't write 1, so we are not writing anything here. And with chloride, we are writing 2. You got it?
Yes.
Okay, please come up to the next page, and I want you to draw a dot and cross model of this one, please.
How do I find out the charges?
You use the periodic table, right?
Okay.
Look at the group number.
There are 3 Mg, so I'll write Mg 3 times in the rough work.
What?
There
And then
are
what?
3 magnesiums, so I'll write down 3 times on the rough work.
No, no, no. Why would you write 3 times? You will just write the number 3 over here. Just like magnesium. Let's say over here we have 3 magnesium. So we will just write over here 3. Are you getting it? Hmm?
Okay.
The first thing that you should do is, first of all, you should split it and then you should write electronic configuration. You know? Okay. Do it. Come on. This is first of all draw for say nitrogen. Okay, nitrogen is in group what? Group 5, right? Okay.
Yeah, with the say,
Are you doing it?
yeah, it's 3 minus.
Why are you drawing nine minus over here? You
What?
don't need to draw minus over here. Just draw nine, right? Nitrogen. Nine.
Hmm.
Beta, the draw bracket a bit closer. Okay. Okay. Hello.
Yes.
Biddy, I was looking into it. This is all correct. It's just this that you should write 3 over here. Okay.
Okay.
All right. Now look. Now we are doing for covalent compound. Okay. In covalent compound, what do we do is that first of all, we do the rough work, okay, and we rearrange the atoms in such a way that they're arranged symmetrically. Are you catching up? Hmm?
Yes.
Hello? Okay.
Yes.
Just give me 1 minute, please. My tablet is connected. I don't know why. Okay, yeah. Okay, fine. So for example, you had C2H4. Okay. So now you will do the rough work. Okay. In rough work, what do you do? In rough work, what do? You arrange the elements symmetrically, okay? So first of all, you place the 2 carbons in the middle, and then you place the 4 hydrogens around it. Are you getting it? Hmm?
Okay.
Now let's say we are drawing a key over here. For carbon, we are giving a cross, and for hydrogen, we are giving a dot. Okay. So for each hydrogen, we are giving a dot, okay? And for each carbon, we are producing 4 electrons. Okay. Now you see what would happen is that this would pair up with this, and this would pair up with this would pair up with this, and this would pair up with this. Are you catching up? Hmm?
Yeah.
Then we'll connect these two and we'll connect these two. Okay. And why are we doing so? Because each atom, okay, needs to have a noble gas electronic configuration. Are you getting that? Hmm?
Yes.
So hydrogen will have maximum 2 electrons in its outermost shell, and carbon will have in total 8 electrons. So you see 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons. Are you getting that? Hmm?
Yes.
Then what do we do? Just wait. So this is 2 carbons, okay, and we'll draw 4 hydrogens, okay. Are you getting that? Hmm? Now
Yeah.
we won't use our brains because our rough work is ready. Okay. So now what we'll see is that in between carbon and hydrogen, we are having 1 dot and 1 cross, right? So we'll write 1 dot and 1 cross here, and then we'll write 1 dot and 1 cross here, 1 dot and 1 cross here, 1 dot and 1 cross here. Okay. And then following up the diagram, we know in between the 2 carbons, we have 4 crosses, right? So we'll follow up this stuff work blindly. Am I clear to you? Hmm?
Yes.
All right. Can you do for this one, please? Please draw it for this. Draw dot and cross model of this one. Can you please align them nicely that you have enough space to do the work? Like if I were you, I would have first of all placed carbons and hydrogens like that, and then I would have placed bromines over here like that, because this is my rough work. Okay, are you getting? So I should have enough space. And remember, the more neat your rough work is, the more accurate your dot and cross model is going to be like. Are you getting?
Yes. How many electrons are there in bromine?
If the group is 7, so how many valence electrons does it have? It would have 7 electrons, no?
Yes.
Wouldn't it? Draw them and link them real quick. Come on. Okay, good. Now draw the main structure. Wait a minute. How come carbon is left over here? No, 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 no. Can't happen. Can't happen at all. Huh? Even over here also you did the same mistake. Tell me, how many electrons more bromine needs in order to complete its outermost shell?
1.
So how come you are borrowing 2 electrons? You can only borrow 1 electron, right? So either this bromine combines up with this carbon or with this carbon. It can't combine with both, and same goes for this bromine. Are you getting that?
So,
Hmm? Yeah?
so I'll bond this like this.
Yeah? Asa, no way, no way. How come? Listen, this electron is already paired up, right? Hmm?
Yes.
So how come it is pairing up again? Huh?
Okay.
Look over here. 1, 2, 3, 4, 5, 6, 7, 8. Omar, listen to me. Omar, let's say I have let's say $100. Okay. And you also have $100. Okay. And there's a car, let's just imagine, okay, and this car is of $200. Okay. So the thing is, what do? We both pool up the money to purchase this car. Are you getting that? So half
Okay.
a month the car stays with me, half a month car stays with you. Are you getting? Hmm?
Yes.
So just like that, bromine pulls up, bromine says to this carbon that look, in order to complete my outermost shell, I need only 1 electron. Can you pair up? So carbon says yes, why not? And they pair up. Now this shared pair of electron goes to bromine once and then goes to carbon once. Okay. Similarly, carbon also pulls up money with this hydrogen. Of course, not money, electron, right? Okay. So this shared pair now goes up to hydrogen once and then to carbon once, and it keeps on rotating like that. Are you getting? Okay. So in this way, bromine would become 1, 2, 3, 4, 5, 6, 7. Like these are the 7 electrons of bromine. And then it would pair up with this. So we'll count it to be the eighth one. Are you getting? Now, bromine doesn't have any capacity to combine up with any more electrons. Now, when we look at this bromine, 1, 2, 3, 4, 5, 6. So can you please remove one of the shared pairs? Because at the moment, we have. थोड़ा सा Okay, bete. So listen over here. Are you getting this, huh?
Yes.
So remove this. Remove this, please.
Remove what?
Hmm. Okay, great. Wait a minute. Wait a minute. The the compound's formula is C2H4Br2. If you combine it with this bromine like that, then this compound is formed and this carbon is not even combined up with something, right? Okay. So what you'll do is you'll pair up this one. Are you getting?
Yeah.
Yes, better. Now what do you do?
Uh,
Now you'll pair up these two now. Only now these two were left to be bonded, right?
yes.
And then you make up the structure over here. Please draw the structure real quick. What are you doing? Huh? Hello.
Yes.
Shouldn't this come up like that? How come you are overlapping the circles? Hmm?
Okay.
These overlaps should not overlap with the other circles.
Okay.
ले लो मुझे नहीं
Like this.
You're not using hydrophore. With this carbon, four things were combined. Two hydrogen, one bromine, and other carbon. You did it correct. Over here, with bromine, you have 6 unbonded electrons. You didn't draw them. Are you getting it? Hmm?
Yeah.
Okay. So inshallah, from here we'll continue tomorrow. Okay. Take care. Allah Hafiz.